How can we stimulate a more conscious use of fertilizer? Many farms use too much fertilizer, which can cause environmental damage, a topic of debate with the recent global nitrogen crisis. In smart farming, sensors are used to measure the properties of soil, including the presence of fertilizer. These are the most frequently used indicators of soil quality reported in literature. Among these are nitrogen, phosphorus, and potassium, of which some can be measured using spectroscopy, working as follows. Infrared spectroscopy measures light within the infrared electromagnetic spectrum by detecting frequencies of infrared light that are absorbed by a molecule. Different wavelengths correspond to different chemicals present in a mixture, such that these can be identified and measured. With this in the back of our heads, we set out to answer the following question: how do we give people insight into the use of fertilizer? We tackle this through a system that can measure not only fertilization chemicals, N, K, and P, but also weather conditions and other soil properties, which influence the uptake of fertilizers. In that way, the amount of applied fertilizer can be altered to the soil's needs. This system is an autonomous field-based sensor system that is meant to be affordable, yet useful and accurate. The literature provides guidance for what sensors are the most appropriate to use for this goal. Rather than talking about the approach, take a look at our prototype. What you see is an Arduino mini computer which connects all the sensors and modules and is responsible for all the logistics between them. The prototype is used by simply sticking a 1-pin probe into the soil that measures the soil temperature and a 2-pin sensor which measures how moist the soil is by running electricity between the 2 pins. The blue sensor does the same thing for air, measuring its temperature and humidity. The display shows all the measurements live. And for when you need to leave the sensors in a field or plant pot, the data storage unit stores the measurements over time on an SD card that you can also remove. As we saw, the chemicals related to fertilization can be measured using a spectrometer, which will also be hooked up to the system. The design enables the user to see which components are used to measure the desired soil properties. The transparency of the design highlights our purpose of making the device as open and accessible to people as possible. The slit at the bottom of the casing enables direct contact for soil with the sensors. The tree motif is not only meant to reflect the agricultural aspect of this device, but also supports the casing and protects the electronic components from unfavorable weather conditions, such as heavy rain, which could cause damage to the components. Data will be collected with the device to ensure reliability and accuracy of the product, and to find ways to improve soil quality. To measure soil conditions, we are planning on making use of agricultural farms within Zealand and the Green Wall initiative of UCR's Eleanor Green office. Once further developed, we hope to make this project as accessible to everyone as possible and hope you find use in it. Thank you for watching.